Good afternoon. Dzień dobry. Every monthly cloud bill is based on resource usage, and a lower footprint your application leaves, less memory and CPU it consumes, the better, the cheaper. And today I will talk about transformation from JVM to native, how to efficiently deploy Java applications in containers in the cloud. And if you are tasked with deploying some Java workload in the cloud, in containers, what would you think about first? How fast it can start? What will be the size of the container? And how much memory to reserve, right? I come from Oracle. I work at Oracle for more than 7 years, and my name is on the slide. And all the time I work in the Graal team, on the Graal projects, not only GraalVM. And we will talk about GraalVM today, of course, a lot. I will ask you to, if you would like to leave a question, which I will answer at the end of the presentation. Use slido.com and the QR code to scan it, and please select the right room. We are in the room number 11. Everyone is familiar, right, since yesterday. And before we move in, let's talk about typical problems of Java containers. And I'm sure we all know about them, and I just list the top, like slow startup time, which affects the cold starts in serverless environments, like AWS Lambda, OK Native. Then Java containers are known to be bulky, because including a full JDK in a container bloats the container up. Then memory consumption, tuning complexity, over or under provisioning memory leads to performance issues, then resource usage at idle, and also improper use of base images. Let's see which of these we can approach today. I will quickly introduce the GraalVM, just a few words. What is native image, native build tools, then how we can compile a Spring Boot application ahead of time in an automated way, and then in a more manual way. And in this case, we'll use Paketo build packs, of course. Then we will talk how to natively deploy a Spring Boot application in a container, and also how to reduce the application size to the minimum, like how to make the container as small as possible so it takes less space. And finally, along the way, we will be deploying these containers as distroless or static, mostly distroless, discussing the trades-off, and then the Q&A session. So what is GraalVM? It's an extension to Oracle JDK. It's a JDK, a full JDK, and you can download it on the same page as Oracle Java, on the Java downloads page. But we have also the website, graalvm.org, and there are more options how to get it. On the downloads page, the easiest one will be SDK man. And what are the differentiators, major differentiators of Oracle GraalVM compared to the base JDK? The Graal compiler. Compiler is a just-in-time compiler replacement to C2. It's written in Java. And this talk is not about the compiler and the optimization it does. The second differentiator is native image, and this is the tooling we will be using today. I will be using extensively today and explaining. And also there is a polyglot APIs, which enable you to package to actually embed other languages code in Java code. And the way you do it today, you just add as dependencies, as Maven dependencies, JavaScript or Python. We maintain these jars, we publish the jars for every release. And Oracle GraalVM is released on the same cadence as Oracle JDK. We have the same licensing model, the same free terms and condition license for 2 years. So if you have any concerns about licensing, please ask me. I will answer at the end. And what is native image? Native image is an ahead-of-time compilation toolchain. It has been mentioned a couple of times yesterday, today, and we will be using it extensively. So what it does, it compiles Java applications ahead of time into a native binary. It can be an executable file or a shared library. And underneath, it employs the GraalJIT compiler to run initializations. And it will be a good solution for microservices deployments, for CLI applications. So what happens actually? The native build tool takes as input the bytecode. It can be in the form of a jar file or a class file or modules. Modules are supported, and at the output you get an executable, which is self-contained, and then it's also dependent on the operating system, on the architecture of your operating system. So if you build it for Linux and it's Arch, and you should deploy it on that same architecture. What happens underneath? At the build time stage, as an input, you can see we pass the application code in the form of bytecode, the GDK libraries, the dependencies, and also substrate VM jars, which is the substrate VM is another specification of a GVM. It's specific for native image. It's for native image runtime. And then the initialization starts. So we initialize, native image initializes all the code, all the static field, methods, classes. And then there is a phase of points to analysis, which determines which of this code will be reachable by your application at runtime. It doesn't mean everything will be reachable. And once this data is marked as reachable, the native image build tool, saves this data. Actually, it runs some optimization on it, like method and optimizations on the method, inlining methods, and then this data is written to the image heap and code in the text section. And as I mentioned at the end, you have a platform-specific executable file. And by the executable file, we can call it an image, we can call it an executable, we can call it a native binary. I mean the same. I will be using these terms a lot today, so I mean the same, a native image. What native image brings to Java containers? Why do we need it? No need of a JVM and at runtime, right? That means we can use some Docker-based images that don't include a full GDK, for example, or at all the JVM. Native image provides instant startup time for Java applications in milliseconds, and then lower memory footprint, and of course, related smaller containers, because if you don't need the JVM, you can use a smaller base image. And lastly, native build tools. This is a Maven and Gradle plugin we develop for making native image build smoother. And also, native build tools allow you not only compile applications ahead of time, but using Maven or Gradle, but also to run JUnit tests as native code on native code. And then also you can use them to create necessary configuration, depends on the Java microservice or application you need. On the left, or right, from your side, right, you see the configuration, the declaration of the Maven plugin. I will be using this Maven plugin today as well and explain more as we go. And for the demo time, let's switch to the demo. I will run a Spring Boot application. The Spring Boot application is not just a web server which serves a dummy Hello World page in the browser. It will be a GraalVM website documentation, the latest release documentation for GraalVM for GDK 24. And we will compile the Spring Boot web server ahead of time. And we will do it in two ways, like Paketo build packs, which is native to, to Spring Boot. And at this build, it will employ the Liberica JVM because that's by default. But it doesn't mean you cannot change Liberica JVM and still use Paketo build packs and run it on GraalVM. You can do that. And second way, we will be using Maven build tools, just Maven on the command line. And it's a more manual way, but it gives you more flexibility in configuration. Let's move on to VS Code. I will run the demo in VS Code, and maybe I should increase the font. Is it visible like so far? And I have a host machine, which is Oracle Linux. You can see I am connected. I am connected to Oracle Linux version 8, and the machine uses. It has 4 CPUs and 48 gigabytes of memory, which is sufficient. I'm connected, so let me let's start. Let's start from the conventional approach. We will just compile it into a fat jar and run it. And we will run it in two ways. First, we will run in a container which uses Eclipse Xamarin for Java 21. And then we will run it using a different distroless Java-based container for Java 21 and compare. But in both cases, we are running a jar file. And I will start the build until it completes, and meanwhile explain. Oh, come on. Yeah, jar, sorry. Yes. As you can see, I have a bunch of Docker files, and for each step, there will be 8 steps today. I will run 8 steps, 8 builds. And for each build, I have a Docker file. It's a multi-stage build. So I am using one builder image with a full GDK, and let's have a look. This one. Is it visible? Is it good enough? OK. So I'm not here to teach you how to write Docker files or how it should be written properly in considering the layering and so on. And for the first image, for the builder stage, I'm using the GraalVM GDK. I pull it from the container registry, and it's Oracle GDK, Oracle GraalVM. And then I run the maven package command, so I get the jar file. And for the runner image, I'm using Eclipse Xamarin. And see, I'm copying the jar file from the build stage. And that's what I'm going to run. And the entry point is a Java launcher, so you specify arguments as for the main class. It completed, but let me run the second build, and then we will compare. Yes. In this stage, in this step, and this is the one, not the one, a moment, this one. What's the difference here? A different base image in the runner container. In the container I'm going to deploy. And what it gives us, so you build in one image, and then you create another image, another container image, which will be smaller. And for this case, I'm using distroless Java 21 Debian. It's still a bit heavy, but not that heavy as Eclipse Xamarin. Before the build completes, let's look in the source of the application. Of course, it's a very plain one, and this is just a web server. It serves one index page, but that index page goes down in the hierarchy and serves all the other documentation pages of the website. So it's just one page to serve. Why would we need a lot? Why would the container be big? We can squeeze it, right? We can slim it down. And let's compare. And the first build completed, and the image which will be deployable is 491 megabyte. The second one, much, much smaller, right? It's a big win, 235. And the distroless Java 21 Debian image has, well, it's not an image for development. You cannot compile the application there. Let me go to the slides, and I have the summary of this image. So it's not a full JVM. It's just a runtime environment for Java 21 in my version. And it's also headless. There is no graphical user support. But there are core Debian libraries, JLibC, like the native libraries, SSL certificates, time zone, network essentials. Java is the entry point, so quite it's sufficient to run a Java application from a jar. There are no Java compiler and tools like Jlink, JConsole, no shells, no package managers. You cannot install anything there. But it's still sufficient, right? And we move towards efficiency. Let's move on. Let me go back to VS Code. What we can do next? We can use Jlink. Who is familiar with Jlink? Okay, it's hard to see. And Jlink is a tool to create a custom runtime. It's a custom runtime image. It was released in Java 11, and it was released in approach to cloud-native development and requirements. It helps you to create a runtime which will only include modules your application will need, actually. So we can do that. Let me start the build. It will take a little bit longer. And let me show you the breakdown of the Docker file. In the first builder image, I'm using the same GDK, Oracle GraalVM GDK. And I create a jar file. This is the jar file a Jlink runtime will run. And then I run the Maven dependency step to determine the class path information and dependencies of the application and write them down to the text file. Then we run the jdeps command. And this command analyzes which module your application will actually need at runtime based on the class path information. And then we run the Jlink. The command for Jlink is quite long, but because I'm trying to remove all extra things, strip down it as much as possible, I don't need the header files, I don't need man pages, I don't need the debugging information in. And see, I'm including the modules that are required. So these modules, the list of modules is generated by the jdeps command. And also I tell, please output it in a directory called Jlink GRE. And then at the builder stage, I'm copying it. See, I'm copying the jar file first, and then I'm copying over the environment, this custom runtime environment. But the difference here is that I'm using now a different base image. It's not Java 21 Debian. It's smaller. It's a Java base Debian. And what's the difference? By the way, I forgot to run the application. Moment. Let's run it from the Jlink runtime now and see if it runs, and then we will see the size reduction and what we gained with Jlink. And let's run it with Docker. Let's map ports. It's 80. And let's run. Well, we can run this one. Well, let's run the Jlink one. It doesn't matter. We can. The startup time. It's not the point. This presentation is not about improving the startup time or performance. We will talk about space saving, but there will be a significant difference, reduction in the startup time between this step and the next step. So right now it's 1 second, 0.142 milliseconds, and it's the same startup time if you run it on the from the previous two containers. I can demonstrate, and let's go to the browser and see if it's running. This is my public API and the port 8080. Yes, it's up and running. These are just documentation pages. Of course, you can use, you can add more pages. You can set the mappings, and the application will get heavier. But you can do that. I'm using just one index page, and from there you can go down to other pages. Absolutely runnable web server. And what will be the interesting part again? Let's check again what was the size. Moment. So we moved down to 188 megabytes. It's minus like 47, right? 47 megabytes from the previous run. But this time we moved to a smaller container image. And plus we use Jlink to create a custom runtime. So we only run the Java launcher from that custom runtime in the Docker container, and there are only modules we need. But what's the benefit of using the Java base over Java 21 Debian? So here, the Java 21 Debian Docker image is 192. But if we go down, if we use smaller one, a stripped down version of the GRE, it will be 128. It's not a full Linux, and it's not a complete Linux distribution. It doesn't have a full GDK, but it has the runtime environment. Then it also can be like, depends which version you need, but you can tag to 17 or 21. It's headless again, but there are some core Debian libraries, and there are time zone files, there are minimal HTC, JLibC, certificates, necessary modules. Java is the entry point. So if we don't run the Jlink there, we can use the Java from this base image. And, well, there are no utilities like bash, ls, shell. There is no debugging tools like jconsole, jdb, no compiler, of course, no package managers. But still, it's sufficient just for a runtime. And now we will move into native. Let's go native. The game changer is GraalVM Native Image. We will use it underneath. And first build that I will run will be based on Paketo build packs. Who is familiar with Paketo build packs? These are good, at least few hands. And these are containers. Like we will use only Paketo build packs in this stage to show you the difference between automated way to create a native executable of this Spring Boot application versus the manual. There will be no dramatical change in the final Docker image size, but I would like you to show the difference. And let's start the build. Actually, it's a Maven command. Let me look it up. I have it, so I don't have to type it. This demo is reproducible. I will share the location where to find it. And there are even more steps and more Docker builds. I had to cut it down because of the time limit. There are also workshop versions of it available with more steps, more Docker files, and also environment which you can just use in the Oracle Cloud. So now the build started. We can see that Paketo pulls some images, and you cannot determine, you cannot influence the process. It pulls some images. This is the builder image. It will run the native image compilation on the Liberica JVM there. And as I mentioned, you don't have to necessarily use Liberica JVM. You can configure in the Maven POM.xml file that you would like to use a different image for the building stage, for generating a native executable. And we also have, Oracle provides a build pack for GraalVM, and this is how you can actually call it. You can map the initial container with the container where would you like your native image to be built on. For this application, it didn't make a lot of sense because it's trivial, it's small, and for larger code base, you might want to do this because in this case, when you use Oracle Paketo build pack with Oracle GraalVM, it gives you more performance. Liberica JVM is based on a community edition. Okay, the build finished. And let's check. Yes, it finished. You see, we have a couple of more unexpected Docker containers, but what we need is this one. This is the name of the container I defined in POM.xml. Let's run it. And the size dropped down to 158. And this time, the size drop down is caused by the fact that we compiled the application ahead of time into a native executable, but we don't have the control over the container, the runner container. So what's inside we cannot control. We don't provide the Docker file for this build. It's provided with Paketo build packs. But just let's run it to check if the application is up. And notice the drop down in the startup from 1 second 0.1 something to 0.0 something. It's only because we compiled it ahead of time. It's a native executable. Startup time drops down significantly. The site should be still up and running, right? Of course, I checked it before. And let me stop it. And now we will run the second build, but this time I will use native build tools. I will use Maven configuration file to configure this build. And this shell script is called dynamic, not because I'm using the building tools, native build tools, but because I'm building a dynamic image, same as before. This is a dynamic native image dependent on the operating system, dependent on the libraries, on the native libraries on your system, also the GDK static shared libraries. That's why it's dynamic. Because we will move into different way of building native executables, less dynamic in a while. While it's building, so Maven pulls in dependencies and see how I pass the profile name. So I'm telling Maven, please use this profile from POM.xml because I want it to be native image, not a jar file. You can pass as many profiles as you like. And it's convenient because you can have every native image build configured differently. You can tell, I want this output file to be called differently. And this way to differentiate between one run and the second run, compare like the runs, compare the performance, the startup, the sizes, and so on. We will do that. We will be using actively Maven profiles for the next steps. The native image build started. There are 8 phases. And we can see in the gray font that this is the output of the native image build. And you can see how much of the data is reachable. It actually breaks down to tell you how much of methods, fields, and actually are reachable by your application and will be written to the native executable. Also, what is your system configuration, like what the garbage collector you use, what is the native compiler on the system, and so on. We are at phase 5, so right now we are inlining the reachable methods. We are doing the optimizations over, and I'm not configuring the build yet. It's just the default build. The file size of the executable should be the same as the previous one. Not the executable, the Docker container that we will deploy should be approximately the same, maybe 1-2 megabytes difference, because that's the same dynamic image that's inside. But this time we have more control over the container we are deploying. And let me show it to you, the container file, Docker file. And notice I am using the same distroless Java-based Debian 12, the same base image for the runner stage as for Jlink. But this time I'm copying over the executable file, and I'm using this executable file as an entry point. So the container just runs, the Docker runs this and this dynamic image. And let's check the sizes. As I said, the size difference should be not dramatic. It's from 158 to 160. If you run it, there should be no difference in startup time, but just to check. Right, the startup time hasn't changed in 0.0 something milliseconds, and the application should be up and running. I still have 20 minutes. I should make it. And as you can see, it's still up and running. Let's terminate, and let's move on. Now we will manipulate a little bit with the image. What if we can compress the executable image, the native image file itself? And for that, GraalVM offers several options. We have an option that is called -OS. And -OS, it includes all the -02 optimizations from the JVM plus the optimizations for file size. The way I configure it, I will start the build to speed up. Come on. Oh, it doesn't respond for someone. Okay, yes, it's here. I call it optimized this time. And how I tell the native image plugin to actually optimize the final output file for size. I use Maven profiles, and for this build, for this run, I'm using the profile called dynamic size optimized. I call this ID of the profile at build time. And right, this is the plugin declaration. This is the name of the final file that I would like to get. And this is the option. You can pass any native image option as you would do it on the command line. You can do it with build arguments in POM XML or this Gradle syntax if you use Gradle. There are plenty other optimization options. Just quickly to show you. Here we just focus on the space saving, but if you would like to optimize it for higher throughput, for better performance, or for better memory usage on the website, docs, then we go to the reference manuals, and then there is optimizations and performance section. Under this section, there are other options listed, like -OB. If you care about the build time, if you think like the build takes too long and you need to speed it up, -OB, but there are some like advantages and disadvantages, right? It may affect the performance. It may not include all the optimizations, but it will be faster. The build will be faster. There are also machine learning inference in the native image building, which you can also activate. It's not like we have two options here. We have two models, and we can optimize for specific machines as well. Not the topic today. It's a whole different topic. Let's just talk about space. I won't make it in 40 minutes, now 18. Okay, and we have the base image, the dynamic image optimized build. Let's check the Docker container sizes now. And it dropped down to 125. We did not change the base image in the container. It's the same Java, distroless Java base. But we compressed the executable file, the one that we packed into that runner container. Believe me, it's still running. Let's quickly run. The startup time, 0.05, the same. And so this is the public website. This is the website we just deployed. And if you go back, it's up and running. Good. What if we go now static a bit? So far, we built dynamic images. They are dependent on the operating system libraries, static libraries from the GTK as well, and GK libraries. But we can manipulate with the image build. And native image supports other options for static linking. I will go to slides to explain the difference with visual elements. This is the build we just did, a dynamic image, fully dynamic. It includes the application code, but everything else should be ported by the environment you run the image in, like in this case, Docker container. And we use Java base because it provides JLibC. JLibC is a native C library on the system. It's heavy. There are other options. We can go half static. We can include some static libraries. The static libraries from the GTK as well, like the shared libraries on the system that application depends on. We can include zlibc, but jlibc would be too much. It's heavy. So we will be half static. But that means we don't need the Java libraries in the environment we are deploying the application in. So in the Docker container, we can use a different Docker image, smaller. And then finally, what we can do, we can go fully static. We can include, instead of jlibc, master-libc. It's a lightweight implementation of the C library on the system. It's much smaller. We can include it in the image, plus other libraries the application depends on. And then the base container could be even base. It could be even empty, like Scratch, like Alpine. We will get to this. I will explain the difference and trades-off. And right now, we will build a mostly static native executable. I will start the build to speed up. And the way I tell my native image the plugin to use to build a mostly static image, I just specify different options. Static, no libc. It tells, please build a static image, but no libc in it, no jlibc in it. And I keep the -OS optimization on. We still need the file size to be as small as minimum. And as you saw, the summary of this image, it's 60% less than the previous without Java libraries, 48.3. It's a stripped down, only, it's not a Linux distro, not a full one. But we have some file systems, some lib files, some minimal HTC files, we have the jlibc, which we need. We have the necessary support for DNS queries, authentication as well, time zone data, certificates, quite a lot for a web server, right? Sufficient, if you run it from or another type of application. But we don't have any shell utilities, no package managers, no SSH support, no debugging tools like Linux tools like curl. We don't have basic commands like ls, ps. So depends. If your application is statically linked against everything except glibc, that works. Let's see how much gain reduction in size we get. It's at the build stage. I was too fast. The build hasn't finished, and you see native image build started. And this is how I specify which profile to use. I tell Maven, please use the default one. It's compulsory. And then you can specify any other profile you would like to. You can list more profiles if you like to. And let's see what we get. What is the size reduction? It's 113. Like, not a lot, 12 megabytes win, but we changed the base image in the container. It's a smaller one. And I forgot to mention, every image we built, even if it's a jar file we built at the beginning, they all include static resources. They all include static pages we have in the resources. So Spring Boot includes them. And that's another reason I chose Spring Boot as a framework for this application, because you don't have to configure native image in any way to pick up the resources. It's all in. And it adds 44 megabytes of size to this image. So it's not only index file, it's plus the static pages. It still runs. Oh, unfortunately too fast. The startup time shouldn't have changed. It shouldn't have changed. It's 0.0 something and milliseconds. And the pages, the website is up and running. And now we go fully static. I will start the build and then go back to the slides and explain what we are doing. And this time we built static image, just static, because we have one more step left after this one. And the way to tell Maven I need the static build, I'm creating another profile for this stage. And this time I tell, please build a fully static image, and please include muscle libc. And of course, the optimization for size are in. You cannot specify optimization for size and then optimization for build time. I want the shorter build time because they will override each other. The build will start in a moment. See, I'm passing a different profile name. And for the base image, by the way, for the base image, I'm using Scratch for this run. Let's see the Docker file. So in the builder, we created a native executable file. At line 5, we create the native executables, fully dynamic. And then we copy it over to a Scratch container, which has nothing in it. And then we just specify this image as an entry point. Let's see if it runs. And before, the breakdown of the Scratch container, 2 megabytes in size, empty base, practically nothing. There is nothing. There is not even a temporary or bin folder or anything. And it's a bit inconvenient, to be honest. If you want to look inside what's there, it's kind of impossible. Well, you can use Sift. You can look what's in, like at least some sizes information. But there are no file system, as I mentioned, no libraries, no compilers, no shells, no package managers. You cannot install anything there. You can only use the Docker copy command and copy whatever you need. But every copy command gives more layers in the image, right? And that's not the best approach. What I would recommend, Alpine, for static applications. It's a little bit bigger, 5 megabytes, but you have a minimal shell. You have the BusyBox shell. You have a package manager. APK means you can install whatever you need. You can install something in this container. There are certificates, SSL certificates. There is muscle libc, utilities like basic one, ls, move, copy, create, directory, and so on. Of course, there are no native compilers like GCC or muscle dev. or system libraries, but more than just a Scratch. I just use Scratch because this type of application does not need anything else. And let's check if it runs. So Docker build finished, images, and what we have, 92.3. This is the last image we got. It's fully static and it's packed in the Scratch container. Let's run it. Up and running. The startup time hasn't changed, right? 0.05. Good, good, it's all up. And the final build. We can go in more extreme. We can slim down the container even more. But this time we cannot use another base image because smaller doesn't exist in Scratch. And by the way, Scratch is an official Docker image. And but we can optimize, we can manipulate with the executable file more. And for that, I will use an open source tool, which is called UPX. And this tool is a file compressor for executables. And we will compress again the native executable and then copy it over it into the Scratch container. I will start the build. UPX. And what happens inside? So we have the same base container image, the same Oracle GraalVM, but here I specify muscle libc also to optimize the sizes of the base images, container images for GraalVM that we published at Oracle Registry. We have GraalVM with just a JDK, or GraalVM plus native image, or GraalVM native image and muscle libc, and I just used muscle libc to simplify. In this way, I have muscle libc in the builder image in the container, so I don't need to install muscle libc and zlibc in the container. I have it already. And then, see, I'm installing UPX tooling. And then I run the native build tool step, the native image step. I have the executable. And then I run UPX on that executable. And I tell it, please use this executable, compress it into this one. What happens? UPX tool downloads this file, executable file, into the system, into the memory. It decompresses and compresses it again. During this phase, you have no control. We don't know what happens, what was optimized out, what happened to the static pages because they also squeezed. And this is this kind of disadvantage, so be careful with that. But still, it's powerful. And then what we do, we copy this compressed executable into the Scratch container again. Oops. What happened? Failed. Create parent directories. Okay, let's try again. Moment, did I run the right build script? Yes. Build static UPX. Oh. What I will do, I will just prune everything out, if you don't mind. And then we will have, like, I have I have the numbers on my slides, and don't worry. What? Good. Empty. It's now empty. Let's run the last step. It will take a minute and a half. To build a native executable for this application, for this web server, we need a minute and a half in normal way, in not optimized build time. And then the UPX compressor takes the stage, so it will take a couple of seconds to decompress and compress the image again. I have 4 minutes left and a half, 4.5. Is it like 50 minutes time or 40 minutes time plus questions? Who knows? Oh, almost there. I will increase. And this is done. Done. Now we have the UPX tool running. I told you it takes a couple of seconds. But let's see if it was worth it. Done. We have it. Let's run it first. Startup time hasn't changed, as expected. It shouldn't have. And the website is up and running. It was compressed. The server was compressed significantly. And if you wonder how much it was compressed, 34.5. So we started at almost 500 megabytes. And we shrinked to, well, I calculated it will be like 34 times smaller, 14 times smaller, sorry, 14 times smaller from the original container image size. And the application is production ready. It's the same documentation you see on the GraalVM website. And it's deployed in this small container in Oracle Linux, in Oracle Cloud. Just to recap, this is where we started, this is where we ended, where we landed. What are the lessons learned today? Not all optimizations are equal. Jlink is useful, but native image is an order of magnitude better in terms of size optimization and also in terms of startup time. Static linking that native image supports allows you to use other smaller base images in containers. Then the base image size matters. If you use the Eclipse Temurin and then you switch to Java 21 DBN, which is like half of it, like it's a JVM runtime, it's a complete JVM runtime for Java 21, not for development, but for running. But still, the drop down in the size of a container was like less than 300 megabytes. And then Spring Boot, you saw Spring Boot and GraalVM play well together. You can easily compile a Spring Boot app ahead of time, and thanks to build tools from like native build tools that we develop, all Paketo build packs, it's easy to do this way. And then the compression was the final boss, the final trick with UPX. It's not something we support, but we just use it. And you can experiment and see how effective it can be for your workload. Try it yourself. The demo is reproducible. This is a workshop session. I have workshop sessions for this presentation as well. And the workshops, if you can, please do it. I will switch. My time ended. Another slide that I wanted to briefly mention, that we have GitHub Actions for GraalVM build, so you can build native images for other operating systems on GitHub. If you have the workflow using GitHub actions for GraalVM. And this is the final slide with resources. And bullet point number 3, luna.oracle.com. This is a workshop platform from Oracle. It's completely interactive. You can run workshops in Oracle Cloud. The ephemeral accounts are created for the time you run the workshop. Once you launch it, you have the necessary Oracle Linux environment. And you can run all the steps I just did, even more. There are more steps in there. There are more workshops. Thank you. And now the time for questions, if I have time. Slido, let's go to. Is this the one? Nope. Nope, that's not the one. Why it's not the one? Slido.oracle.com. Sorry, slido.com. Mm-hmm. And good, room 11. A moment, I see, yeah. See. Okay. The first question. How supporting a native image app on production look like compared to JVM app? Do we have things like JVM monitor? Yes, we do have GMX monitoring, metrics, debugging support. So like we have the necessary tool to monitor your application up and running. And for that, if you go to GraalVM.org guides, for example, it's easy to find, monitor, here you go, find it, like try. Then, can you build it as a raw native executable without container? Of course you can. I could do that on the on this Linux machine. I had 48 gigabytes of memory. I could build it on this Linux machine, and then I could copy the file from local to the container and then run it. Does it answer the question? What benefits you see for corporate enterprise applications where image size or boot time is not #1 priority? And then probably we'll consider if you use an enterprise version of GraalVM performance aspect. You will probably enable profile-guided optimizations, like the same optimizations for that other, like on the JVM. And maybe, like in that regard, you will consider how many requests per second your application can run. Well, if I understood the question well, because I'm not sure. And then also the license, because Oracle GraalVM has this free terms of use license for 2 years. So for running up enterprise apps, if you can always keep to the latest, upgrade to the latest LTS release, it's just win. You are in the good position. Next, just want to ask if removing shell and bash from image is a good idea. Do you have possibility to enter the? Yeah, depends what you need to do with that container. If you would like to shell in and see what's inside and work with it, then yes, it's not convenient. If you just deploy this type of application like microservice or web server, then you don't have to do much, right? You develop locally, you can build locally and then copy over to this basic container. Will using GraalVM Native Image require same license as using Oracle GDK for business production use? Yes. Well, again, if you use the latest LTS release, it's free for 2 years, but then you cannot distribute native image file. The executable file you create with native image, you cannot distribute it for money. Then you will need a license. But you can use it for your own purposes, not for reselling. How does the Docker image size impact Docker RAM CPU usage? We didn't measure that, but it impacts. I should have measured probably. Like it's a good topic. What is the performance correlation in runtime between Spring Boot app with heavy business logic and input-output calls in native image versus the JVM with runtime optimization? Well, not an easy question. Again, here you will probably use not the size optimizations, not the build time optimization, but highest throughput optimizations for faster response. But let's talk about it more. And then the last, where can we get this showcase? Let me show you again this slide with the QR code where you can get the workshop and the demo. And the last question, how long did it take you to optimize this build so much? We have a bunch of demos for GraalVM on GitHub, and there are similar kind of demos, and then you just go down by down. It's basically a Docker file which you massage with, which you change the from base image, and that's it. It didn't require me that much time. And just to GraalVM demos. So if you go here, there are a bunch of demos with for different use cases. They are tested against the latest JDK release, against the new release that is coming soon, the early access build for JDK 25. And for the workshop, for this demo that I just demonstrated, please, this is where I can get it, under my GitHub profile. We also have workshops, as I mentioned, on Oracle platform for workshops. It's also there, so you can just run it in Oracle Linux, in Oracle Cloud, without installing anything on your machine. And I hope I answered most of the questions, at least some of this answered. Thank you. If you have more questions, I'm free to answer. And sorry for taking longer than I should.